This is part 3 of the video on chapter 43, parametric equations. And we're going to look at example 256. And in example 256, we're given 4 sets of parametric equations and we're given 4 graphs. And we want to match the equations with the graphs. If we look at the first one, x is 2 sine t, y is 3 cosine t plus t minus 1. We notice that x is bounded between -2 and 2. Y is unbounded. As t tends to infinity, y tends to infinity because of this term. As t tends to negative infinity, y tends to negative infinity. And so of the 4 curves, we look at the one that we just described, and that is graph 4. The x is bounded between -2 and +2. The y is unbounded. As t increases, y increases. As t decreases, y decreases. So the equations in part A match graph 4. For part B, both x and y are bounded. So x is bounded between -9 and +7, and y is bounded between -5 and +7. And so the only graph that has both x and y bounded is graph number 1. So graph 1 matches the equations in part B. If we look at C, what happens here, both x and y are unbounded. But because y is a quadratic that opens upward, y is bounded below but not above. Here, x is neither bounded above nor below. As t gets large, x gets large. As t gets small, x gets small. So, which of these graphs match this description? It's going to be the third one. Y is bounded below but not above. X is not bounded in either direction. Finally, part D, these are kind of strange looking equations. But let's notice something. Sine is an odd function, cosine is an even function. T itself is an odd function. An odd function times an odd function is even. So x is an even function. An even function times an odd function is odd. So y is an odd function. So that means when you substitute t or -t in for x, you get the same thing. When you substitute t and -t in for the y expression, you have opposites. And so this means for every point xy that's on the curve, x negative y is also on the curve. And the curve that matches that description is graph 2.